Hello everyone, I am very happy that I have this opportunity to share our design with you. We are DYBP and our members are Liao Shixun, Zhou Nianyao, and Chen Hongguang. On this page are our specification of work. First of all, the current area is 93121 and the operation time is 19.26. From the above result, we can see that our biggest problem is the huge area consumption, so we are still working hard to optimize this performance. The improvement target is to replace the state machine to reduce the area by 20% to 30%. Reduce time consumption by 20%. The following content is component we use the time, including 8-bit comparator, shift register, 131-bit adder, 131-bit register, and 2 counter and 1 multiplexer. And this is our algorithm, including maximum, minimum, average, extract, exclude, peak max, and peak minimum. And it's our flowchart. To get the maximum value in function 1, first store the value in register and then use the 8-bit comparator to compare the value in memory. The larger ones are retained and the smaller ones are deleted. Continue until the group 128-bit is compared. Find the maximum value and output it. And function 2, minimum. The circuit function is similar to circuit 1, but its function is to find the minimum value. And next, function 3. To get the average value, first use the 131-bit temporary register to store the value. Then add the value with the RCA adder 131 adder and take the largest 128-bit as the output. Function 4, extract. Function 5, exclude. Find the value within the range is the extract function. Because the range is fixed, we first make a truth table and then use K-map to find a Boolean function in it. When the value meets our gate level, it is stored. And function 5, we need to find a value outside the range. Because the range is fixed, so it's similar to function 4. We make a truth table and use K-map to find a Boolean function. And then function 6, peak max, and function 7, peak minimum. The circuit is an extension of circuit 1. In circuit 1, we perform an output every time a set of 128-bit value is complete input. In this circuit, the output is only performed when all 96 sets of data are input. And the peak minimum is similar to peak max. And this is our main architecture. Function 1. In function 1, we can see the 8-bit counter, a temporary register, and a comparator are used. When a set of data is input, the counter will send a down signal to the comparator and start the comparison replace work. Function 2 is similar to function 1, but it can obtain the minimum value. In function 3, we can see that there is a memory and 131-bit adder and a counter. When the counter calculates a set of value and complete the input, it will output the average of this set of value. In function 4 and 5, we implement the Boolean function with a circuit. We can use this gate-level circuit to determine extract and exclude. Function 6 and 7 are extensions of function 1 and function 2. Their output will only be compared after all values have been input. The circuit architecture is similar to 1 and 2. Known and to be learned issue. Known issue. First, specify the header or other component form. 2. Learn to write database. 3. Use a state machine. In the first one, we coding with a high abstraction level. And 2, we need to learn how to write a automatic test bench. And the third, we use too much state machine. To be learned issue. Use the gate level to accurately judge the module. Although it is very convenient to write code using high abstraction level syntax, because we want to optimize area or time, we must use the gate level to describe the adder or subtractor to achieve the best result. The second, the current test bench only has a small part of the data, so we cannot rule out the possibility that only part of the function are correct. Therefore, we want to build a database to implement automatic function. As for the database, it is impossible to create all the information by handwriting, so our current idea is to use other programming language to automatically generate the content of the database, and then use this information to write test bench. We currently use state machine writing method for many function conversion. But the disadvantage of the state machine is that it has a large area, although there are already other modules to cooperate. That is, other characteristics are used to create long-lasting but small area components. But the best way to optimize is to find other modules or algorithms to solve such shortcomings. At present, it has been successfully implemented according to the last concept presentation. First one, basic coding. There were a lot of syntax errors in the previous circuit, and then there were even latch in some parts. And we eliminate the error and confirm that at least there is no complication problem. Although the information is not very beautiful, at least make sure their basic coding work is complete first. Synthesis and testing. After coding is successful, the circuit is successfully synthesized, and a small part of the value need to be proofed. We did more self-writing corner tests and correct more semantic error from them. And third, data collection and optimization. When reading the data, I found that most of the places where latch occur are in the writing of case. Through the content of the data, we can successfully modify the part that we generate latch. In addition, the get level part can be used smoothly to handle function 4 and 5, successfully save a lot of area to complete the optimized work. And this is our synthesized result analyzed. And the figure in the left hand side is our synthesized circuit. And in our circuit, we enter the value through shifter. Use counter to detect whether the test value is entered, and using adder using the average. To do this, The first one is to analyze the content of report from other group. And the second one is collect data to optimize the final design. 3. Optimize design. 4. Use C++ or other programming language to write a database and make a more complete test bench. And the synthesis circuit. And the final one is report production. And it's our progress schedule. Analyze the content of other group report before December 29th to January 1st. Optimize the final design about December 29th to January 3rd. Use software to design test bench database about December 30 to January 4th. Synthesis and testing about December 31st and January 4th. Prepare the final report about January 3 to January 7. January 3rd. And it's our possible issue and expect solution. Then we can manually divide the problem we can foresee and the expected solution into 3 parts. Anticipate question. First, reduce over reliance on state machine. Although the state machine make our writing method clear, but the state machine will make our area too large. Expect solution. We want to find a module or change algorithm to replace the state machine. And the second part, waste of the same module. We have successfully merged module 1, 2, 6, and 7 so far. But modules 4, 5, and some component of function 3 are not be reused. Expect solution. If we want to make the result better, we will find way to increase its efficiency. But because module 4 and 5 have been written in gate level, so specifically for element 3. Third, test unknown calculation result. At present, we can output successfully, but the value provided are not actually all calculation results. And the third part, expected solution. Use other software language to write out the remaining possible result, and then use the data library to generate test bench for testing. And this is our presentation. Thank you for your listening.